Removing colons in R tidyverse is an easy task. You can use the minus symbol in front of a specific column name to exclude it from the return data frame that will then retain all the rest of the columns. Compare it with the initial IKEA data frame here. To exclude more than one column, you simply wrap them in a vector and then place the minus sign on the left. Recall that to be able to store the resulting extracted data frame, you need to assign it to a new variable name. In Julia, you can use the helper function not that takes as its argument a column name or an array of column names that you want to be excluded from the resulting new data frame. Notice that the bang at the end of select signifies that you don't need to store the result with a new assignment to a new variable name as happened in R, and it is the initial IKEA data frame that is changed. Following the R-Ladies tutorial, to extract those columns whose names end with E or start with des, you have the corresponding functions. While checking whether there are columns that include an underscore in their name, you can use the contains function. Julia, apart from its own starts with and ends with functions, allows the direct use of regular expressions for doing these string-related column selections, the $sign for checking whether there are column names that end with E, the current sign before des to signify that we want all names that start with des, and the combination of the dot and the asterisk operators for getting back the columns that contain an underscore anywhere in their names. To select ranges of columns in tidyverse, you can use the range notation with the colon symbol that signifies the from and the to columns that we want to extract from IKEA, be they column names or indices or a combination of both. To use its own select function with ranges of columns, Julia offers the between column selector. Its two arguments specify the range of columns, the from column and the to column that can be specified as in R either by column names, column indices, or a combination of both. Filtering out DataFrame rows sets R and Julia apart in terms of both notation and implementation. R's tidyverse uses filter and a vectorized condition to extract rows of the price column that have values greater than 8,500, for example. Julia, on the other hand, has a multitude of ways of extracting these exact same rows. Julia's filter takes an anonymous function as its first argument and the data frame name in the second position. The underscore is to override the default first position that IKEA takes when it's passed with the chain macro to the functions within the begin block. You can either set an anonymous function in two ways using row, which is an internally recognized variable, or the pair symbol of the mini transformation language defined by Bogomil Kaminsky. R-Ladies included two more examples of filtering out rows. The first filtering was based on equality checking for extracting those rows whose price is exactly $2.65. And the second on returning those rows whose names are either of the three string values of the vector on the right. Julia uses filter with an anonymous function that defines the same filtering criteria as earlier, be they equality checking or string membership. For filtering out rows based on complex conditions, R-Ladies included the following two examples. The first returns the DataFrame rows that take the value beds on the category column and the value yes on the other underscore colors column. The second example results in a subset of the initial IKEA data frame based on another complex condition. Julia, in its anonymous function, offers a similar notation with respect to the same complex conditions with minor differences. For example, the logical AND operator is denoted with a double ampersand, while vectors, as always, are denoted with brackets.